Hello students, let's do exponents. Exercise 2b. Exercise 2b is on page number 33. Question 8. Show that. Now we have to show that this is equal to this. That means this is the left hand side and 1 is on the right hand side. We have to prove that the left hand side is equal to the right hand side. That means we have to work out all this here and our answer should be equal to 1. So let's begin by working out this. So here, as you can see, we have x to the power of a divided by x to the power of minus b, and the whole thing is raised to the power of x minus b. Now here, since the base is the same and it is division, we can subtract the powers. So let's begin by doing that. So this is going to be x to the power of a minus the power of the x which is in the denominator, which is minus b. Okay, now this whole thing is now raised to the power of a minus b. So what did we do here? We have subtracted the powers. That's why we wrote a minus b, and this whole thing is raised to the power of a minus b. Now this dot here stands for multiplication. So let's put that dot here. So that is multiplication. And here also we can do the same thing. Since the base is the same, we can subtract the powers b minus c. So let's do that. So this will be x raised to the power of b minus c. And this whole thing is now raised to the power of b minus c. Again, it's multiplication. Let's go to the next one. Here also, as you can see, the base is the same. So we can subtract the powers because it is division. So here we can say x into x raised to the power of c minus a, and this whole thing is raised to the power of c minus a, and this should be equal to 1. So now this whole thing that we can see here, this whole thing is the left hand side. So we are only going to work on the left hand side. So let's write that left hand side. We're only going to work on this and see whether this is equal to 1. So this is equal to, now here let's solve this one here, x raised to the power of a minus into minus is plus, a plus b raised to the power of a minus b into x raised to the power of b plus c, because minus into minus is plus, and this whole thing is raised to the power of b minus c into x raised to the power of c plus a, because minus into minus is plus, and this whole thing is raised to the power of c minus a. So this is the left hand side and this is the right hand side. So we're going to leave the right hand side as it is there. We're not going to, there's nothing to do there. It's equal to 1. So we're only working on the left hand side. Now here we have x raised to the power of a plus b, which is raised to the power of a minus b, and we know that a plus b and a minus b, because we can since we can apply the power law, it becomes multiplication. So this is equal to x raised to the power of a plus b into a minus b into, this is also raised to the power of b plus c into b minus c, because we are applying the power law here, into x raised to the power of c plus a into c minus a. Now here, since we have a plus b, a minus b, b plus c, b minus c, c plus a, c minus a, that means one is the sum, one is the product, we can apply the algebraic identities, which says here, as you can see, a plus b into a minus b is equal to a square minus b square. So instead of writing this and solving this whole thing, taking a long time and simplifying it, straight away we can say a square minus b square. So here this will be x raised to the power of a square minus b square into, here also we can do that, b plus c into b minus c, we can write it as b square minus c square. So this will be into x raised to the power of b square minus c square. Again, for the next one also we can do that, x raised to the power of c square minus a square. So this will be c square minus a square. Now here again, as you can see, the base is the same and it is multiplication. That means we can add up the powers. So here we can write this as x raised to the power of a square minus b square plus b square minus c square plus c square minus a square. So here what do we have now? So here as you can see we have a square and minus a square which will get cancelled. A square and a square will get cancelled. Then we have minus b square and plus b square that will also get cancelled. And again here we have minus c square plus c square which will also get cancelled. So this is x is raised to the power of 0. Anything raised to the power of 0 is 1. So we can see that x is raised to the power of 0 is 1. That means the left hand side is equal to 1 and the right hand side is equal to 1. So we have proved that the left hand side is equal to the right hand side because after working out left hand side we got 1 and on the right hand side also we have 1. So left hand side is equal to right hand side, hence we have proved this. Question 9, evaluate. So here we have x here and again here also we have x raised to a power raised once again and division by again the base is x. So first let's simplify this. So here what do we have? Here we have x raised to the power of 5 plus n into x to the power of, now we have 2 raised to the power once again of 3n to the power of 3n plus 1. That means we can multiply the powers. So this will now become 2 into 3n plus 1. And this whole thing is divided by x to the power of 7n minus 2. So let's write this as it is, x to the power of 5 plus n into. Now let's work on this part. 2 into 3n plus 1. Let's work it out here. So 2 into 3n plus 1. So how do we do this? We take this and we multiply first with 3n. So 2 into 3 is 6, 6n. Then we multiply it with plus 1. So 2 into 1 is 2. Okay, 2 into plus 1 is plus 2. So we have 6n plus 2. So now we write x raised to the power of 6n plus 2. How did we get that? We solved this and we got 6n plus 2. So we have raised it to the power of 6n plus 2. Now this whole thing is divided by x raised to the power of 7n minus 2. So here now let's look at the numerator. Here the base is the same. So and it is multiplication. We can add up the powers. So this will become x raised to the power of 5 plus n plus 6n plus 2. And in the denominator we have x raised to the power of 7n minus 2. So here again let's write that x raised to the power of, let's take the whole numbers. 5 plus 2 is 7. So that is 7, and then we have here we have n plus 6n which is 7n. So 7 plus 7n, and we normally write the number later. So we can write, instead of writing 7 plus 7n, we can write 7n plus 7, 7n plus 7. Now in the denominator what do we have? X raised to the power of 7n minus 2. So now can you see the base is the same, it's division, that means we can subtract the powers. So this will now become x raised to the power of 7n plus 7 minus 7n minus 2. So this is x raised to the power of 7n minus 7. Now we're going to open the brackets. When we open the brackets, change the sign of all the terms inside because we have a minus here. So this becomes minus 7n plus 2. So here as you can see we have 7n minus 7n which will get cancelled and we only have now 7 plus 2. That is 7 plus 2 is 9. So this becomes x to the power of 9. And this is our final answer. X to the power of 9. Question 10, evaluate. So we've been given this. Now you should look carefully and see how can we make things easier. Now what should we do first? Now look at this one. This we can leave it as it is. Now look at this a with, we have the powers like this, 2n plus 1 and 2n minus 1. Now how can we solve this and make this easier? Now this is multiplication, but one is addition, one is subtraction. That means we can apply the algebraic identities which says a plus b into a minus b equals a square minus b square. So we just have to write the square of 2n and 1 and put the subtraction sign. So that is how we can solve this. Now here what do we do? Here we can apply the power law and multiply the powers. Similarly, here also we can apply the power law and multiply the powers. So let's begin. So here the first thing is a to the power of 2n plus 1. The first one we are writing it as it is, into a to the power of, now this one 2n plus 1 into 2n minus 1. We are applying the algebraic identities and writing a square minus b square, that is 2n the whole square, that will be a, and b is 1 square. So in the denominator, what do we have? A to the power of n into 4n plus 4n minus 1, so that is 4n minus 1 into a to the power of 2 into 2n plus 3. So now this will become a to the power of 2n plus 1, we are writing it as it is equal to, now look at this one, a to the power of 2n raised to the power of 2, 2n square, that means 2 square and n square, 2 square is 4 and n square, so that will be 4n square. So this will be into, this is not equal to, it is into a to the power of 2n square is 4n square minus 1 square is 1 into 1, which is 1. So that we have solved. Now here a to the power of n into 4n minus 1. So let's do that. N into 4n minus 1. So how do we multiply this? Take this n first, n into 4n. N into 4n is 4n square. Then multiplied by minus 1, which is minus n. So here instead of this, we're going to write 4n square minus n. So this is 4n square minus n into, now let's take up this part, that is 2 into 2n plus 3. So that is 2 into 2n plus 3. Let's do that multiplication. So 2 into 2n, that will be 4n. Then 2 into plus 3 is plus 6. So instead of writing this, we're going to write 4n plus 6. So that will be a raised to the power of 4n plus 6. Now let's look at what is the numerator. Here the base is the same, so we can add up the powers. Again here also the base is the same, we can add up the powers. So let's write that. So this is equal to a to the power of 2n plus 1 plus 4n square minus 1. Now divided by, similarly here also a to the power of 4n square minus n plus 4n plus 6. So now let's continue. Now here 2n plus 4n square, both are unlike terms, so you cannot add them, whereas plus 1 minus 1 will get cancelled, that is equal to 0. So what do we have in the numerator? We have a raised to the power of 4n square plus 2n. So that is 4n square plus 2n. I have put the square first because we are writing in the descending order of the powers. Now let's look at the denominator. Denominator here we have 4n square, that's it, no other n square, but we have minus n and we have plus 4n. So these two we can work out. So let's write that. So in the denominator, that is divided by a to the power of 4n square as it is, we write. Now minus n plus 4n will become minus 1 plus 4, which is plus 3. So that is plus 3n plus 6. Now the powers are the same, we can subtract the power. So this will be a to the power of 4n square plus 2n minus whatever is there in the denominator, which is 4n square plus 3n plus 6. So this is equal to a to the power of, so now let's open the bracket. So this is 4n square plus 2n. Now this minus before the bracket, so change the sign of all the terms inside the bracket. So minus 4n square minus 3n minus 6. Now here what can we work out? So here we have 4n square minus 4n square. We can cancel that because that will become 0. Then here we have plus 2n minus 3n, that will become minus 1n. Okay, so that is a to the power of minus 1n means minus n minus 6. Now this we can write it as a to the power of minus, put only minus before the bracket and put n plus 6 inside the bracket. Now if I open the bracket, what will I get? Minus n minus 6, I'll get back the same thing. Now, why have I done this? So that I can get my answer in a positive index, positive power. So a raised to the power of minus n plus 6. Since the power is negative, we can write the reciprocal of this and change the power to positive. So this becomes 1 by a. A now becomes 1 by a raised to the power of n plus 6, where the power has now become positive. So this is our answer, 1 by a raised to the power of n plus 6. Question 11. Prove that the left-hand side is equal to the right-hand side. So this is the left-hand side and this is the right-hand side. Left-hand side, right-hand side, and we have to prove that they are equal. So let's take only the left-hand side first. So what do we have here? We have m plus n raised to the power of minus 1 into m raised to the power of minus 1 plus n raised to the power of minus 1. So what we're going to do first is change them all to positive powers. So here it is minus 1. To change it to a positive power and make it 1, we have to write the reciprocal. So this becomes 1 by m plus n to the power of minus 1 to the power of 1. Okay, so we leave it as it is into, now here what do we have? M to the power of minus 1. If I write the positive power, it becomes 1 by m plus this will become 1 by n. Okay, so now this we're going to leave it as it is for now, m plus n, and we're going to work on the next one, into. Now here we have addition of fractions. So when we add fractions, we normally find the LCM. Now LCM of numbers we know how to do. How do you find the LCM of variables? You write the product. That means you multiply. M into n is mn. That means our LCM is mn. Now, to make it easier for you, take this first fraction, that is 1 by m, and multiply it by mn. So that will be 1 by m into mn. This is just to make your work easier, especially when you have variables. So cancel off the m's. What is left is only n, which you can write here. N plus, similarly, take 1 by n and multiply it with the LCM, which is mn. Now here what will get cancelled? The n's get cancelled, and what is left is only the m, which you can write here. Okay, so now we have this. Now here what do we have? So let's write this again as it is, 1 by m plus n into, now here we have n plus m. We can rewrite it as m plus n. It's the same thing. So this is m plus n by mn. So this is mn. As it is we've written. Now since it's multiplication, we can do cancelling. So this m plus n and this m plus n I can cancel. So how do I get this now? Now what is left is 1 by mn. So that means on the left hand side I have 1 by mn. Let's write that. So on the left hand side we have 1 by mn. Now on the right hand side what do we have? On the right hand side, as you can see, we have mn to the power of minus 1. So let's write that down here. So on the right hand side, we have mn raised to the power of minus 1. So this one, if I have to change it to a positive power, what will I get? I will get 1 by mn, because I have to write the reciprocal, raised to the power of 1. So now on the right hand side we have 1 by mn, and on the left hand side also we have 1 by mn. Can you see? So left hand side is equal to the right hand side. So let's write that left hand side is equal to the right hand side. So hence we have proved it. What have we proved? We have proved that the left hand side, which is 1 by mn, is equal to the right hand side, which is also 1 by mn. Question 12. Prove that. So here also it's proof. So we have left hand side and we have the right hand side. This is the left hand side and this is the right hand side. We have to prove that the left hand side is equal to 1. So we have to work out the whole thing. So left hand side we have to prove that it is equal to 1. So let's do this slowly and carefully. So first look at this. Here we have x to the power of a by x to the power of b, the whole thing raised to the power of 1 by ab. So first what we can do is, since it's division and the base is the same, we can subtract the powers. So here we can write x raised to the power of a minus b, this whole thing raised to the power of 1 by ab, into Similarly, we can do for the next one because base is the same. X to the power of b minus c, the whole thing raised to the power of 1 by bc. Next one, x to the power of c minus a and the whole thing raised to the power of 1 by ca. Now here we can apply the power law. We can multiply this power and this similarly here and here. So let's do that. So this will be x to the power of a minus b, put that into brackets, into 1 by ab. It's multiplication into x to the power of b minus c into 1 by bc into x to the power of c minus a into 1 by ca. Now when you multiply this, a minus b into 1 is a minus b. So we can write this as x to the power of a minus b by ab into x to the power of b minus c by bc into x to the power of c minus a by ca. Now here the base is the same and it is multiplication. That means we can add up all these powers. So now we can write this as x to the power of a minus b by ab plus the next power which is b minus c by bc plus the next power which is c minus a by ca. Now let's take these. Look at the powers. They're all fractions and it is addition. So we have to find the LCM and work it out. So let's do this working separately here. So let's take only the powers. So that is a minus b by ab plus b minus c by bc plus c minus a by ca. Again, since we have to find the LCM, remember these are not numbers but variables and it's not easy, very easy. You just have to think carefully and do. Take a, now there's only one a, so we can write a into b into c. Now look for the highest power of each. Each one's power is only 1. Suppose I had a square, then that will be, if suppose this was a square and this is a, my LCM will have a square, the highest power. But here all powers are 1. So I can just write one of each, that is a, b and c. Now here, what do? I take the first fraction and I multiply it with the LCM like I showed you in the previous one. So here let's do that. Take the first fraction a minus b by ab, multiply this by abc. Now here, because it's multiplication, I can cancel a and a, b and b. So what do I have? A minus b into c, which I will write here, c into a minus b. So that is the first part. So I took the first fraction and I multiplied it with my LCM and this is what I got. Now I'm going to take my second fraction and multiply it with the LCM just like this. So my second fraction is b minus c by bc. Now take the LCM and multiply into abc. Now cancel what you can. I can cancel b and c and b and c. So what do I have now? I just have a into b minus c, which I can write here. So this is a into b minus c plus similarly with the last fraction. Take the last fraction as it is, c minus a by ca, multiply it with the LCM which is abc. Now cancel, I can cancel a and c. So what do I have? B, so b into c minus a. So I need to write that plus b into c minus a. Now we're going to work this out by multiplying c into a minus b, a into b minus c and b into c minus a. So here let's do that. So this becomes c into a, which is ca or ac, minus c into b is cb or bc, plus let's go to the next one. A into b is ab and a into minus c is minus ac. Next here b into c is bc and b into a is minus ab or baab, and in the denominator we have abc. Now here let's look at all the numerators that we have. Now here we have ac and minus ac, which will get cancelled. Then let's go to the next one. Here we have minus bc plus bc, that will also get cancelled. Then we have plus ab minus ab, that will also get cancelled. So what do we have here finally? Finally, here we have 0 by a, b, c. So let's write that here. So now this is x raised to the power of 0 by a, b, c. Okay, now 0 by anything is equal to 0. So this will become x raised to the power of 0. And x raised to the power of 0 is 1. So that means on the left hand side we just got 1. Now on the right hand side, what do we have? On the right hand side also we have 1 as it's shown in the question. You can see right hand side is 1. So left hand side we got 1. Right hand side we got 1. That means left hand side is equal to right hand side and we have proved it. So the first question we have been able to prove that the left hand side is equal to the right hand side. Question 2. Now here also we have to prove that the left hand side is equal to the right hand side and this is the left hand side. Okay, so let's look at the left hand side alone and we're going to work it out so that our answer becomes 1. So let's take the first part of the left hand side, that is 1 by 1 plus x to the power of a minus b. Now look very carefully. I'm going to write this 1 as it is. So 1 we will write as it is. Now in the denominator I have 1 plus x to the power of a minus b. Now this 1, now look at the working column. 1 is equal to x to the power of 0 or anything raised to the power of 0 is equal to 1. We know that, isn't it? Now how do I get x to the power of 0 based on this part? So suppose I write x to the power of a minus a. How much is a minus a? 0. And x to the power of 0 is equal to 1. So instead of writing 1, I'm going to write x to the power of a minus a because that is also equal to 1. So here, instead of writing 1, I'm going to write x to the power of a minus a. A minus a. That is instead of 1. So that's not b, that's a minus a. And then plus the rest of it remains the same, x to the power of a minus b. Now go to the next one. Similarly, 1 by, now here again we have 1. So instead of 1, I'm going to write it as x to the power of b minus b, just like this. Okay, so instead of 1, I'm going to write x to the power of b minus b. How much is b minus b? 0. So x to the power of 0 is 1. So instead of 1, I have written this. Then continue by writing x to the power of b minus a. Again, see what I'm going to do here. I'm going to write 1 by, now here we've got x to the power of a minus a. That is, if I add a plus minus a, I will get a minus a, isn't it? That is, suppose I write it here like this, a, x to the power of a minus a is actually x to the power of a, x to the power of a plus minus a, isn't it? Which is equal to x to the power of a minus a. It's the same thing. So what I'm trying to say is, if the base is the same, we add up powers, isn't it? So let's make the base the same. So instead of writing x to the power of a minus a, I'm going to write x to the power of a into x to the power of minus a. Here the powers are the same. Okay, the base is the same, so I can add up the powers. So when I add up the powers, I will still get a minus a. So this I have separated it as x to the power of a into x to the power of minus a. Similarly here, I can say x to the power of a into x to the power of minus b. So let me write that, plus x to the power of a into x to the power of minus b. I can do the same thing here. So 1 by, I can write x to the power of b into x to the power of minus b plus x to the power of b into x to the power of minus a. Okay, now why did I do this? I'll show you in the next step. So 1 by, now here you can see x to the power of a into x to the power of minus a plus x to the power of a, again we have x to the power of a twice into x to the power of minus b. So since we have this twice, we can take it out as a common factor. So x to the power of a into, I can put the rest in brackets, which is x to the power of minus a plus x to the power of minus b. Similarly, I can do it here also. So I can write 1 by, now see what is common. So I have x to the power of b and again x to the power of b. So that is common. I can take that out. x to the power of b into, in brackets I have x to the power of minus b plus x to the power of minus a. So now what I'm going to do is I'm going to write this first one as it is, 1 by x to the power of a into x to the power of minus a plus x to the power of minus b plus, now here I'm going to write 1 by x to the power of b, and I'm going to rewrite this, that is x to the power of minus b plus x to the power of minus a. I'm going to put x to the power of minus a first. So even if I change the order, there's no difference. So because it's addition, x to the power of minus a plus x to the power of minus b. Now can you see we've got it like this, x to the power of minus a and x to the power of minus b on both sides here, and here we have x to the power of a and here we have x to the power of b. In the next step, I'm going to take only what is within brackets first. So let me write that. So this is going to be 1 by x to the power of x to the power of minus a plus x to the power of minus b. It's common to both, isn't it? Into, now I'm going to take these, that is 1 by x to the power of a and 1 by x to the power of b. So that will be into 1, let's put that in brackets, 1 by x to the power of a plus 1 by x to the power of b. So I hope you've understood what I did here. So what I've taken is I've taken the common one and I've got a fraction here into, and I've taken this x to the power of a, x to the power of b, and I've written it here. So now what do we have? We have 1 by, first fraction as it is, let's write x to the power of minus a plus x to the power of minus b. Now what can we do with the next one? Here, as you can see, we have the reciprocal of this, isn't it? Now if I have to write x to the power of a on top, my power becomes negative. So I'm going to change this to the negative powers. So this becomes into x to the power of minus a plus x to the power of minus b. So now can you see here, this is multiplication. Here we have minus a plus x to the power of minus b into x to the power of minus a into x to the power of minus b. These two can be cancelled. So this and this can be cancelled. And what do we have left? We have 1 left. That means on the left hand side we have 1 as our answer, and on the right hand side also we have been given 1. That means left hand side is equal to the right hand side, and we have proved it. Question 13, find the value of n. Okay, so based on this, we have to find the value of n here. So here we have 12 to the power of minus 5 into 12 to the power of 2n plus 1. So when base is the same and it is multiplication, you can add up the powers. So let's keep that in mind and start our working. So here it was going to be 12 raised to the power of minus 5 plus 2n plus 1. So that will be 2n plus 1 is equal to. Now on the other side also the base is the same and it's division. That means we can subtract the powers. So this is going to be 12 raised to the power of 13 minus 7. So this is 12 raised to the power of, let's take the whole numbers, minus 5 plus 1. Signs are different. Put the sign the bigger number and subtract. 5 minus 1 is 4. Minus 4 plus 2n. And here 12 raised to the power of 13 minus 7 is 6. Okay, see, on the left hand side we have 12 raised to the power of this much, and on the right hand side we have again 12 raised to the power of 6. So the base is the same on both sides. If base is the same, that means the powers also are the same. So base is 12, which is equal to 12. That means minus 4 plus 2n is equal to 6. So let's write that down. So minus 4 plus 2n is equal to 6. Now we can find the value of 2n. 2n is equal to 6 plus 4. 6 plus 4. So 2n is equal to 10. That means n is equal to 10 divided by 2, because 2n means 2 into n. So when we take 2 from there, it comes to the other side and becomes division. So n is equal to 10 by 2, that is 2 5s are 10. So we have found the value of n here. N is equal to 5. That was a question. Find the value of n, and we have found the value of n for the first question to be equal to 5. Here also we have to find the value of n. So first let's work on the power law and multiply the powers. So the first part here is a to the power of 2n minus 3 remains the same into a to the power of here it is 2 into n plus 1. And in the denominator we have a raised to the power of 4 into minus 3. This is equal to, here also apply the power law, a raised to the power of 3 into 3 divided by a raised to the power of 6 into minus 3. Let's simplify this further. So this is a raised to the power of 2n minus 3 as it is into a raised to the power of, now let's multiply. So here when you multiply, first you do 2 into n. So 2 into n is 2n and then you multiply 2 into 1. 2 ones are 2. So that is plus 2. Now down divided by a raised to the power of 4 into minus 3 is minus 12. This is equal to a raised to the power of 3 3's are 9 divided by a raised to the power of 6 into minus 3 minus 18. Now here when the base is the same we can add up the powers, isn't it? So let's apply that law. Now that is a raised to the power of 2n minus 3 plus 2n plus 2 divided by a raised to the power of minus 12. Now this is equal to, here it is division and the base is the same, that means we can subtract the powers. So this becomes a raised to the power of 9 minus 18. Now let's work on this here. So here we have 2n plus 2n. So this is 2n plus 2n which makes it 4n. So that is a raised to the power of 4n, and then we have minus 3 plus 2 which is minus 1. And in the denominator we have a raised to the power of minus 12, and on the other side a raised to the power of 9. Now minus into minus is plus, 9 plus 18. So this is equal to a raised to the power of 4n minus 1. Now the base is the same and it's division, that means we subtract the powers. So we can take this to the numerator. We are subtracting the power, that is we are subtracting minus 12. So this is equal to a raised to the power of 9 plus 18 is 27. So this is a raised to the power of 4n. Now here we have minus 1 plus 12, which is equal to a raised to the power of 27. Now let's continue on the other side. So here we can say, I'm taking this to the other side, a raised to the power of 4n minus 1 plus 12. So let's write that, a raised to the power of 4n. Now minus 1 plus 12 is plus 11. Plus 11. This is equal to a raised to the power of 27. So this is in the form of an equation now. Now here, as you can see, the base is equal. It says equal, isn't it? If the base is equal, that means the powers also are equal. So in that case, we can say 4n plus 11 is equal to 27. Only the powers. So I've taken only the powers because we need to find the value of n, and they are equal because the base is equal. Now we can find the value of 4n by saying 4n is equal to 27 minus 11, because we have transposed plus 11 to the other side, it's become minus 11. Now we know the value of 4n. 4n is equal to 16. So now we can find the value of n. 4n means 4 into n. So when it goes to the other side, it becomes division. 16 divided by 4. 4 4s are 16. So now we have found the value of n. N is equal to 4. So we have found our answer. N is equal to 4. Lesson 14, simplify. So here let's work this out. Just let's write it as it is into a, and now let's multiply these two. So let's write what's given to us. So we have been given a to the power of 2n plus 3. Now next one is we're going to multiply a raised to the power of 2n plus 1 into n plus 2. Now 2n plus 1 into n plus 2. Now we have learned multiplication of binomials. So we're going to take this first one, 2n into the whole of the second binomial, plus the next one, that is plus 1 into the whole of the binomial, n plus 2. So here we're going to work out first 2n into n and then 2n into 2. So what do we get here? So this is 2n into n is 2n square plus 2n into 2 is 4n. Similarly, on the other side, we're going to do 1 into n and 1 into plus 2. So 1 into anything will give us back that other number, isn't it? So here it is n plus 2. So this will be 2n square, and here we have 4n plus n makes it 5n plus 2. So what we have got here, is after we simplified this multiplication. So let's write this as the power here. So here it's going to be a raised to the power of 2n square plus 5n plus 2. Now here what do we have? Here we have a raised to the power of 3 into, using the power law, that will be 3 into 2n plus 1 into, again, a raised to the power of n into 2n plus 1 is already given to us. Now let's simplify it further. Now here the base is the same, it's multiplication, so we add up the powers. So this is going to be a raised to the power of 2n plus 3 plus 2n square plus 5n plus 2. Now down what do we have? Here we have a raised to the power of, now let's do the multiplication, 3 into 2n and 3 into 1. So 3 into 2n is 6n and 3 into 1 is 3 plus 3 into, here also let's multiply a raised to the power of n into 2n, which is 2n square plus n into 1. So that is n itself. Now further simplification when we do, this is a raised to the power of. Now here we have 2n plus 5n, that is 7n. First let's write the highest power, that is 2n square, then we have 7n, then take the numbers, we have plus 3 plus 2, which makes it plus 5. Now here in the base, what do we have? A raised to the power of, now again it's multiplication, so we can add up the powers. So here it becomes 6n plus 3 plus 2n square plus n. So this will now be, the first one remains the same, a raised to the power of 2n square plus 7n plus 5 divided by a raised to the power of, again here let's take the highest power first, which is 2n square, and let's write it 2n square. Then let's take 6n plus n, which makes it 7n plus 7n, and here we have plus 3. So let's write that plus 3. So now let's continue. Here the base is the same, isn't it? A and A, the base is the same. That means we can subtract the powers. So let's do this by the side now. So here I'm going to take this to the other side and I'm going to subtract the powers. So this is now going to be a raised to the power of, now on top we have 2n square plus 7n plus 5 as it is. We're going to subtract the other powers, which is down, that is minus 2n square plus 7n plus 3. So now this is going to be a raised to the power of 2n square plus 7n plus 5 minus 2n square minus 7n minus 3. So now here let's see if we can cancel something. So we have 2n square and minus 2n square cancel. We have 7n and minus 7n cancel. Now here we have plus 5 minus 3. So this is equal to a to the power of 5 minus 3. So this is finally a to the power of 2, which is our final answer. A to the power of 2 is our answer. Question 2. So let's begin this. Here let's apply the power law and work this out first. So let's begin by writing this as it is. So this is x to the power of 2n plus 7 into x to the power of 2 into 3n plus 2. We have used the power law here, divided by x to the power of, now here it is 4 into 2n plus 3. So first 4 into 2n. 4 into 2 is 8, 8n plus 4 into 3, that is 12. So this is x to the power of 2n plus 7 into x to the power of, now let's multiply here, 2 into 3n first. So that is 2 3s are 6, 6n. Then we multiply 2 into plus 2, which is plus 4, 6n plus 4. Then here down we have x to the power of 8n plus 12. Now when when the base is the same, we can add up the powers. So here it's multiplication and the base is the same. So let's add up these powers. So this will be x to the power of 2n plus 7 plus 6n plus 4. And down here we have x to the power of 8n plus 12. So this is x to the power of, let's take the like terms. Now 2n plus 6n is 8n. So that is 8n plus, here we have 7 plus 4, which is 11. 8n plus 11. So let's write that. And here in the denominator, we have x raised to the power of 8n plus 12. Now let's continue. Now here, when we continue this, here as you can see, the base is the same and it's division. That means we can subtract the powers. So I'm going to continue here. So this is equal to x to the power of 8n plus 11, and we are subtracting the powers now. So minus 8n plus 12. So this is equal to x to the power of 8n plus 11, and minus is there. So minus 8n minus 12. Now here we can look at 8n and minus 8n. We can cancel. Now we have 11 minus 12. So that is minus 1. So x to the power of minus 1. Since the power is negative, we can make it a positive power by writing the reciprocal. So x will now become 1 by x raised to the power of 1, which is the same thing. So this is our final answer, 1 by x. So with this, children, we have come to the end of this exercise. Thank you, children.